Design elements influencing SMT assembly. Smart devices should perform well to satisfy consumers who want high-density devices. The surface mount technology or SMT helps develop high-end electronics. The process of SMT involves soldering, which goes through different problems due to PCB pads, reflow technology, stencil design, quality of the soldering paste, and different technical parameters. SMT manufacturing involves many challenges and different design elements influence it. The supplier needs Gerber files and design data for the placement of components. Gerber files help configure different SMT manufacturing machines and develop stencils for placing the solder paste on the circuit board. The manufacturer and designer should discuss the design parameters and elements for precise SMT manufacturing. So, different elements affect the quality of SMT that we will discuss below. Making bill of materials, BOM. SMT has various features and BOM is one of them. The flow of soldering has close contact with the bill of materials. You have to consider the below factors to create a high-quality SMT. Components packaging should be compatible with mounting requirements. The component figure should be according to the SMT requirements to get the desired shape with precise dimensions. The PC board pad soldering should be compatible with the reflow technology to prevent its oxidation, and the same applies to the solderable ends of the elements. If these two factors get polluted, it would result in defective solderings, such as solder beads or pseudo-soldering. The same is true regarding the humidity sensor and PCB administration. PCB Pad Design. PCB design highly influences the manufacturing of SMT in terms of quality. According to HP research, 80% of SMT manufacturing defects occur due to the poor design of a PCB. So, the designer should focus on essential factors, including the folder mask, layout of components, type of the substrate substance, thermal pad design, assembly techniques, component packages, the position of vias, optical positioning, and the transmission boundary. If the PCB pad design is poor, it would result in deflected soldering even if the mounting position is fine. Like, tombstoning or disposition of components can happen. You can avoid these issues by considering the key aspects while designing the SMT pad, such as the distance between the pads, residual size of the pads, width and symmetry regarding pads, and avoiding through-hole vias. Printing of solder paste. The paste of solder should have a compatible printing technology, or it will affect soldering. A poor printing of solder paste results in a deflected PCB that you have to revise. During the printing of solder paste, you should consider three essential elements, such as solder paste, scraper, and stencil. Quality of the solder paste. Solder paste is an integral part of reflow soldering, and it's a combination of alloy and flux. Precise soldering joints depend on the powder of alloy, whereas the flux removes oxidation from the surface to ensure high-end soldering. Even, the paste of solder having 50% of solder of alloy can be enough if it has high quality. Two key factors of soldering paste, including storage and application, determine its quality. Make sure to store the solder paste at appropriate temperatures ranging from 0 to 10 degrees. PCB stencil. The pad of the PCB should have evenly applied solder paste through a stencil, which is a major factor in printed circuit board printing. Moreover, the eminence of the stencil affects the printing eminence. The stencil is designed through different techniques, including laser cutting, and chemical corrosion. You can design stencils by considering certain characteristics, such as, the thickness of the steel sheet, aperture design, mark points, anti-solder ball processing, direction of printing, type of scraper. In terms of shape and material printing parameters, you have to consider essential parameters of printing for precise results, such as frequency, scraper speed, scraper pressure, stencil's down release speed, and its cleaning mode. Both pressure and speed of scraper should be well balanced, like not so low or so high. If these values are not balanced, it would result in defective printing, thus influencing the manufacturing. Right equipment. There should be accurate equipment to have high-level printing of the soldering paste. A small space and high-density PCB should follow the right printing rules for a stable process. Understanding PCB support. The printing of the soldering paste depends on the PCB support, as its lack can result in an uneven soldering paste. So, it is important to have uniform PCB support to keep the PCB and stencil close enough. Components mounting. The mounting of the PCB parts or components depends on different elements, including the right pressure for mounting, the quality of the components, and their precise location. Components should be according to the BOM, and mounted on the PCB at the right place, following the right dimensions. At the same time, the mounter should be precise in this case to ensure a stable mounting of the components onto the PCB pads. The mounting angle should be correct. Besides, the mounting pressure should be suitable, like not too high or low. You can evaluate mounting through different elements, such as the thickness of the board, components package, mounted Z-axis, and nozzles pressure. Quality of reflow soldering. The temperature curves of the reflow soldering should be well set to have high quality soldering of areas to be welded. An increased temperature can affect the PCBA due to heat occurring at a fast rate. It would cause PCB deformation, damaging the components. Besides, the soldering paste has a solvent that gets volatile, splashing out the metal composites as tins plating balls. Engineers apply nitrogen reflow soldering to get rid of oxidation, enhancing the quality of soldering. Moreover, make sure that the reflow soldering is compatible with the PCB substrate, size, material, weight, and thickness. Besides, it should be according to the reflow oven structure, and the temperature zone's length should also be considered. SMT assembly is easy to optimize by having the best PCB design and software to analyze it. The right design software helps you to set assembly standards without missing any factor. Additional information. The solder paste is applied to the pads through a machine by holding the stencil tightly on the PCB. Then components are placed according to the footprints with the help of optic technology. The engineers inspect the placement of the components through an optic machine to make sure it's free from flaws, and this should be done before reflow soldering. Sometimes the X-ray technology is used for inspection, which is essential before PCB testing. Such inspection helps detect poor solder joints, as well as short circuits that happen during the reflow soldering. The placement machines are unable to hold a PCB if the PCB edge is crowded with components, and this can influence SMT manufacturing. You also have to consider the tooling strips for miniature PCBs. The tooling strips should be at least 6 mm to help a machine have a proper grip during the PCB assembly. You can also give the V-score on the tooling strips to separate the parts easily in the later stage. Keeping the SMT components in one direction can also reduce the flaws and helps have placement the components in one go. So, the selection of the components and their placement affects the SMT assembly, making it smooth or horrible. Frequently asked questions. What is PCB? PCB is an abbreviation of printed circuit board. It is used in electrical devices to provide them with signals or currents to operate. Printed circuit boards are used in different industries, including networking, electronics industry, gadgets, aerospace, and much more. What is SMT in PCB? SMT stands for Surface Mount Technology, and it helps develop high-end electrical devices. What is soldering in PCB? Soldering is a manufacturing technique in PCB where two metals are connected through another material's fusion. It should be precise because poor soldering results in a device malfunction. What are important characteristics of a stencil design in PCB? Stencil design depends on certain characteristics, such as the thickness of the steel sheet, aperture design, mark points, anti-solder ball processing, the direction of printing, and the type of the scraper in terms of shape and material. Final thoughts. Smart devices should perform well to satisfy consumers who want high-density devices. The surface mount technology or SMT helps develop high-end electronics. The process of SMT involves soldering, which goes through different problems due to PCB pads, reflow technology, stencil design, quality of the soldering paste, and different technical parameters. SMT manufacturing involves many challenges and different design elements influence it. PCB design highly influences the manufacturing of SMT in terms of quality. According to HP research, 80% of SMT manufacturing defects occur due to the poor design of a PCB. The PCB designer should focus on essential factors, including the folder mask, layout of components, type of the substrate substance, thermal pad design, assembly techniques, component packages, and the position of vias, optical positioning, and the transmission boundary. Like to know more about the design elements or PC board fabrication? Write us at sales@pnconline.com.